This particular session is about erosion control. It will also overlap a little bit to sediment control. We're going to talk about slopes. We're going to talk a little bit about matting, revegetation, and some other more recent examples of erosion control that have occurred around Oahu. Bare slopes need protection. This is a very significant problem on a lot of our construction projects. If they're over 15 feet in height, you need to install velocity dissipation devices. This is part of the DOT specifications and Section 209 of the specifications. Now, these can also include things like interceptor ditches, and we'll give you some examples of some of these devices in a little bit. You can also need to consider your temporary and permanent stabilization, and we'll talk about some time frames on that in a little bit. What you want to do is prevent sheet flow down the face of an exposed slope. And this picture on the left gives you a really good indication of why. The sheet flow actually collapses silt fence. Now, this silt fence is not your typical silt fence. This thing is backed with wire. So it's a lot stronger than your normal run-of-the-mill silt fence installation. Notice the sediment has wiped it out in one area as a prelude down the slope. On the right, they put in both biosocks at the top, and these were staked, and intermittent biosocks further down. And for those of you over here, we're talking about the top of slope and the intermediate dissipation devices. As I said, and this is a quote out of Section 209 of the DOT specifications, install velocity dissipation measures when exposing erodible surfaces greater than 15 feet in height. They should be about halfway up on a slope that's 15 feet. If you have a very long slope, you need to consider several layers of dissipation devices. Biosock seems to be the most common that contractors use. Pro wattles have an application for this. Silt fence, interceptor ditches. The slide on the bottom is showing you two sets of dissipation devices, and these were actually straw wattles. Whatever you use, they have to be installed per manufacturer's specifications. These straw wattles are actually in a shallow trench, and they're staked down. Stabilization of any bare area needs to occur if the area is at final grade, or you're not going to work it for an extended period of time. That extended period of time by HAR 1155 Appendix C, and this is also reiterated in your SWIP, is 14 days. If you happen to be discharging to impaired waters, it's 7 days. That does not mean at day 14 you go out and run a piece of equipment up and down. That doesn't work. Active construction. If you're not going to work it, you need to start temporary stabilization, and we will cover several methods of that. But two here are listed: hydromulch or cover it. I mentioned interceptor ditches. This is out on the first H1 addition modifications of Kapolei interchange project. They put interceptor ditches at the top of all the slopes, and they used rock. There is a mistake on this side. Down here it says rock 8 to 12 feet. It should be 8 to 12 inches. When you install these check dams anywhere on your project, you need to think smile. They need to be lower in the middle than either side. You want to slow down the water and channel it. In fact, these work so well at the top of slopes, DOT decided to retain them, so they are still there today. I mentioned hydromulch. If you hydromulch an area, you need to make sure before you do, you have plenty of tactifier in it. Hydromulch provides some erosion protection, but not very well. As you can see from these, there is significant erosion in these areas, even though they are hydromulched. When an inspector comes out and looks at your slope, the first thing that's going to catch their eye is the eroded area. And then they're going to start looking to see what else you have in that area. This particular slope, there were no interceptors. There was nothing at the top of the slope. I mentioned you can cover. You can use fabric. You can use plastic. Plastic is probably the best because it's not permeable. These pictures were taken out at Iaa Stream. That stream was being scoured on one side and the banks eroded. So what they did is, it's tough to see in this, but there is a shotcrete wall up there. It was supposed to extend past that, but they ran into design issues with some of the structures in the area. So what they have done, and this is the area that's supposed to also be shotcreted, is they covered it in plastic. They anchored it very well at the top and at the bottom and weighted it down. What I hear is people are reluctant to cover it because they're afraid it's going to blow. If you anchor it properly and anchor it very well, you're good to go. But yes, it can blow. You also need to monitor any plastic you put out there or fabric for degradation. We all know our sun eats up the plastic. Erosion control matting. There is a wide variety out there. There's biodegradable. There is non-biodegradable. Going to talk a little bit about soil preparation is important. And when I say soil preparation, that's more in terms of the construction requirements than BMP, but it enters into it. You have to have complete contact with the ground. If you don't have contact with the ground, you're going to end up with soil under the matting sloughing off and possibly breaking out of your matting. If you have to start another roll partway down the slope, you install like house shingles with the upper one over the lower one. You anchor top and bottom, and you watch for, and I'll talk about watching for irrigation leaks and, excuse me. Anchorage. When I look at anchorage, I look for anchorage installed per manual. You can use the manufacturer's installation instructions if they are given for your product. The manufacturer's staple and staking guidance and the BMP guidance are starting points. That doesn't mean if you count up and it was every 3 feet and you count up precisely how many stakes, that's all you need for it. You need to have complete contact with the ground. This is the manual. It shows a top anchorage, a terminal anchorage. It also shows you how to put in interceptor or check slots. That's so you can break up the matting partway down the slope to provide a stopgap or kind of like an interceptor on the slope. Now I mentioned if manufacturer's anchorage is given. The two pictures on here, the two diagrams, I realize you can't read those, but it's the same manufacturer, two different products. The one on the left is for the common matting that contractors will pick up. It shows you how to anchor it at the top. It shows you how to stake the overlap and everything. It tells you the spacing. What it does not tell you is how to anchor the bottom. It has a little statement down there, and it says, consult with independent professional for further installation guidance. For us, that is the B&P manual. The one on the right is the same manufacturer, different product. They give a terminal anchorage. So they do think about how to anchor the bottom. And in that case, you can use that anchorage. When I inspect, I look at the anchorage. I look at the layering. I make sure it has good contact with the ground. And I'll look at the staking. Here's an example of anchorage per the manual. At the top, you notice there's matting on both sides of a red area. That's where they trenched it, backfilled it. It's awaiting mulch before they flip the flat back over. And they're doing the same thing in the bottom. This is an example of very poor anchorage. They laid the matting down and they shoved a little dirt over the edge at the top. They did not even bother to anchor the sides to the slope. The one on the left shows you what I mean about that is incorrect overlap. The slope runs this way, so they have that bottom piece on top of the upper slope. However, it does have good contact with the ground. The one on the right, what they're doing is they're slipping another piece under the one up above. And there's very good contact. And this one also has a intermittent check slot in it. This is what happens when you don't have good contact with the ground. It's very obvious. It's rippled. You're supposed to lay out the fabric. You're not supposed to stretch it, but you're supposed to lay it out, and it's to have full contact with the ground. And then it's staked in place. On the right, the staking is not complete, but you can see how they're forming it to the ground on the right side of the intermittent check slot. Over here. And up here, they have an interceptor ditch to channel water. You need to use authorized stakes. Tree trunks are not authorized stakes. You'd be surprised what you can find out there. And on the right, this is a very good laying of the matting on top of the ground. You notice the full contact. You notice plenty of stakes. There was one problem. Termites like stakes. They came back at this particular site, and this was on H2, and the termites had eaten out part of their stakes. I talked about soil preparation, and this gets into the realm of the actual engineering of the project. This particular slope was on Kauai. They'd done an excellent job of installing the matting. The problem here was when they redid the slope, they added 6 inches of loosely compacted topsoil. They had a severe rain. It blew out at the bottom and the seams. Now, across the road, the same company installed matting on a much steeper slope that held. This one, the problem was the ground soil was loosely compacted and it just got totally saturated. This picture was taken well after cleanup had started. It was a mess. I mentioned watching for irrigation line leakage. Most of the time we put irrigation lines or the trunk line across the top of the slope. You need to periodically check to make sure it's not leaking. You cannot see the top of this slope. It's up here somewhere. And that's where the irrigation lines were, and they were leaking. They did not realize they were leaking. That, coupled with rain, brought down the slope. And this was that heavy-duty, I think it's Tensar, the real heavy-duty plastic matting with ground anchors that have been drilled into the slope. It brought the slope down. So watch your irrigation lines. This revegetation is one of the best stabilization methods we have. And again, you revegetate when it's either final grade, not to be worked for more than 14 days unless you use some other temporary stabilization method. If it's impaired waters, I keep turning that on, it's 7 days. And again, running equipment over the site every 14 days doesn't cut it. It has to be active work. The vegetation coverage depends on whether or not you're part of a landscaping plan or whether or not you're just revegetating disturbed areas. Landscaping plan, you follow the plan. DOT specs usually call for 98% coverage, have a weed content, all that sort of stuff. Revegetating for just disturbance is 70% of the pre-existing. That doesn't mean if the area was bare when you started and you have pictures to prove it, you cannot walk away. You must attempt revegetation. Right now, today, we are spending over $6 million revegetating slopes that haven't had any grass on them for years. So you must make a contractor best effort. And it's DOT owners that will decide whether that effort was sufficient or not. And lack of dedicated water supply is a challenge, not an excuse. This is why vegetation is so important. These two slopes were side by side. The one on the right was actually over here on this slope, over on that side. Same day, same storm. You can see what 3 to 4 weeks growth will do for your area. If you're doing a large area, and it was mentioned this morning also, a good stabilization technique is slope roughening. This is where you drive your track up and down to leave little indentations. It holds the water and it holds the seed. This is a better example of how tracking can hold this. It doesn't wash everything off the area. This is key with watering the grass. Most contractors have water truck. They can bring it out to water it. Other examples of erosion control. Riprap. A lot of times we would put it at the outfall to keep the ground from scouring out. This is Kaaba on the left side, where Cam Highway was getting eaten away by the surf. They came out and they put a lot of riprap there. The two on the middle and the right show two things. Use of general riprap at the outlet, and also why vegetation is important. Before they remat it at the end of that concrete swale, it was starting to erode out. Once grass grew, it held. Here's an example of a product that was just used on one of our projects. It's called a concrete armor unit. The picture on the left is the pre-installation of the area. Now the armor units are actually these things in the bottom of underneath that particular drain. They look like jacks that are positioned in place of riprap. Around the outside they use concrete fabric that they molded it and anchored, then wet it down to let it dry. This is something that they used on the guardrail. It's the first time I've heard it being used here. I'm not going to attempt to pronounce it, but these are net bags that are filled with rock, and they can be molded into the area. And they are held in place by this mini guardrail behind it. This is out in Wahiawa if you want to go take a look at it. Not Wahiawa, Waimanalo. Right near Waimanalo Beach Park and Bell Street.